Okay, year 8. So, moving on from last lesson where we started talking about acids, today we're going to be talking about alkalis. So, new page in your book, give yourself the title Alkalis, and then what I want you to do is just look at these 3 questions that I've got which recap the work from last lesson. Alright, so question number 1, acids can be corrosive. What does that mean? Number 2, what safety precautions should you take when handling acids? And number 3, what is the difference between a concentrated and a dilute solution? Alright, so pause the video and try and answer those 3 questions. You don't need to write the questions out, but you can answer in a full sentence if you want. Okay, so pause that video now. Right, so you should have got the corrosive means that it could burn your skin or your eyes. Okay, so it can cause burns. Remember, not all acids are corrosive. Some acids you eat, we quite like them. But some acids in the lab especially can be quite dangerous. So what safety precautions should you take when handling acids? Always, always, always wear goggles. Okay, and then sometimes maybe wear gloves, but number 1 is the goggles. And what is the difference between a concentrated and a dilute solution? Remember, a concentrated solution, if you remember, a solution means dissolved in water. So when we talk about a concentrated solution, we mean a lot of the acid dissolved in water. And a dilute solution means not very much of the acid dissolved in water. Okay, so now that we've gone over that recap of acids, we can start talking about alkalis. All right, now alkalis are the chemical opposites of acids. All right, so once we get into the lab, we'll be able to start looking at the actual acids and the alkalis, and you'll be able to see that what these look like and what kind of reactions they do. But for now, we just have to know that acids are the chemical opposites of alkalis are the chemical opposites of acids. And things that you might find alkalis in around the house. So with the acids, obviously we found them in a lot of foods. You'll find them in other places as well. But with alkalis, they're quite common in soap and in toothpaste. You can actually find them in drain cleaner as well. But they've all got this very soapy feel to them. So sometimes when you've got soap on your hands, it has that soapy feel. Alkalis generally all have that soapy feel. Okay, now just like with acids, okay, these are obviously very safe. Okay, and quite useful. However, just like with acids, some alkalis can be quite dangerous. All right, so people often think about acids being dangerous, but like we saw last lesson, some acids may be dangerous, some acids not so dangerous. Same with alkalis. So things like soap, obviously perfectly safe. You might want to go now and use some soap to wash your hands, but also some alkalis can be quite dangerous. All right, so what we need to start doing is differentiating between these different types of acids and alkalis. So I keep saying that some might be safe, some might not be safe. So is there a way of telling which ones are safe, which ones are not safe? And there is. Okay, so we have here something called the pH scale. This is it here. This is the pH scale. Very exciting. Okay, down here on the very left hand end of the pH scale, we've got 1. And at the very right hand end of the pH scale, we've got 14. And right in the middle of the pH scale is 7. Okay, now if something is down here and we say it has a pH of 1, we can call it acidic. And at this end, if it's got a pH of 14, we can call it alkaline. Okay, so what we can do is we can measure the pH of an acid or alkali and put it on a scale. Okay, now there are different ways to measure pH, and we'll do some of those experiments in the labs when we get the chance. Okay, but it's just kind of, it's like a property of the solution. So if the pH comes out as 1, we know it's going to be an acid. If it comes out as 14, it's going to be an alkali. And if it comes out in the middle as 7, we call it neutral. Okay, and that means not acid and not alkali. So it's neither. In fact, water has a pH of about 7. Okay, so why is this useful? Well, it's useful because as you go along the scale, so as you go from 9, 10, 11, 12, 13, things become more alkaline. And as you go down the scale, as you go from 5 to 4 to 3 to 2, things become more acidic. So, obviously, something like vinegar that you put on your chips, okay, it's not going to be right down here. Okay, that would be too acidic. It's going to be somewhere further up. And the soap that you wash your hands with, okay, it's not going to be right up here at pH 14. It's too alkaline. It's dangerous. So it's going to be down here somewhere. Maybe a nice pH of 8 or 9, something like that. Okay, so if we have two solutions, here are two solutions here. Okay, and I have this solution which has a pH of less than 7, and you should all be familiar with this symbol here, which means less than. If it's got a pH of less than 7, that means that it's this end of the scale. Okay, so it means that here I've got an acid. All right, and if I've got this solution and my pH is above 7, okay, remember this symbol here means greater than, then it means that I'm at this end of the scale, and what I've got in this solution is an alkali. Okay, so that's how the pH scale works, and you need to remember that anything less than 7 is acidic, anything greater than 7 is alkali, and anything that's neutral is in the middle with a pH of 7. So it's probably worth now, you can put here on a flashcard, you could have pH of less than 7, pH equal to 7, and pH greater than 7. And then these are our three situations, A, B, and C. And then on the other side you could have, well, A is going to be acidic, B is going to be neutral, and C is going to be alkaline. Okay, right, good job.